So let's now finally move to the query class, and let's just look at the most simple example we could think of. Let's again have our good friend, the result variable, and what we could do is go root query, query, and since we wanted a list, go to list. Save that. And as we already saw with the query builder, if we just do a basic query without selectors on the root element, we basically get the whole hierarchy. Now, what we didn't question a lot so far is that we were always doing our queries on the root element. And obviously that's possible because that way you can ensure that you are searching through all the elements that are in the hierarchy that is beneath this root element. But if your hierarchy is big, this might not be the most efficient thing to do. And it's definitely not something that you have to do, because you could also grab yourself another element. Like in this case, we will grab this container element. If you look at the hierarchy, this is this element here. And now when we run the same query on this element, we can see we get a smaller selection, which is only containing this container and the elements beneath it. So you can think of this in the sense that whatever element you are putting in here, you are querying this subtree of your hierarchy, right? So in this case, this is our new kind of root element that we are starting at, and we are querying all the elements beneath it. And obviously, just to bring that point home, we can also do that on any element that we have. So in this case, let's say we start with this element. Obviously, there's not much to query beneath this element because there's only one element beneath it. But in theory, you can obviously do just that. And in some cases, that might even make sense when you only want to search in a small subtree. So let's save that. And as we would expect, we get the element itself and its only child, which is this label with the 2 here. Okay, so I hope that makes sense. You don't always have to query on the root. Obviously, one other advantage that this has is in computing wise. Now imagine that you have a huge hierarchy with dynamic elements, with sub-elements and whatever. Then obviously searching this hierarchy is does take much more resources than just searching a small subtree, because here in this case you would only have 2 elements to search. That is obviously much less if you would have, I don't know, hundreds of elements at your root. For the next examples, let's now just stick with this container element as our root node to search on. So I will go back to this here, and that's how we are going to do our next queries. So if you paid attention, you might have noticed that we did something a little bit special here already. Before, when we were using Q, we could not only not provide anything here, we always provided a name or a class name. With query, you can basically provide this thing empty, and then you would just get this just a kind of virgin query builder object, just as we had before, without anything selected yet. And that's why we always got all the elements in the hierarchy of this root element. So that's something special. If you don't want to select for any specific name or a specific type or a specific class name, then you can just leave this empty here, don't provide any parameter, and then you will get the whole hierarchy, and on that you can then start selecting if you need some other select than class or name. But obviously, as before, let's just repeat this for a second. We can obviously use the name and class name just as before. So let's just show that for a second here. I can say I want the element with the name label1, which is this, this element here. Let's just see if that works. Yes, we get the first label. And obviously, similarly, we can also search for class names. Let's comment the first one out. Now you can see I can provide the class name here just as we did with Q. Now you can see if I uncomment those and kind of compare them, we didn't provide, the default version is assuming that you are providing a name. So you don't have to write the name here. I could also do this like that, but I can do it with this. I can say that I'm looking for the name. Now it's kind of explicit, and now this is kind of corresponding exactly to what you do with the class name here. So let's just see if this also works with the class name as we would expect. What are we expecting to get? We want to get those 3 square elements because they are having this USS class on them. Okay, so far this is actually very similar to what we had with Q, with the only difference that we are not getting one element but a list, because we are calling the toList here basically. Now, we did not look a lot at other things that we can do with those selections. Now, they are actually pretty much self-explanatory, I think, but let's just try them. No, we do not want a fist. We want the first element. Okay, and now obviously when we want the first element, this is not a list anymore, but this is just a visual element. And I hope it's clear to you that this is basically analogous to just having a UQuery with the class name. Okay, so let's just see what that gives us. Sure enough, we get the first element, just as we would expect. We can also get a specific element at a specific index. Let's say we want the element at index 1. And if you are a really good computer scientist, you probably know which element we are going to get. Oh, I made a mistake. I didn't save, and that would be kind of the result for not so good computer scientists. But obviously the first index is the second element since we start counting at 0. And one other option would be to, for example, also get the last element, but I don't think that I have to show this here now. Obviously, those things just help you to kind of to get quicker to the elements that you actually need. Obviously, with that index, you could basically get an arbitrary element. However, always one element. So now let's see if we have the need to do something with several elements or with all the elements in our selection. There are also options for that. And so we know that we have our selection here that is giving us all the elements with this class name. And let's say we want to do something with all of them. For that, we have the for each method here that is expecting a lambda or arrow function. For those of you who know this from the web, and this will be very familiar. What you have to do is you are kind of looping over the elements in your selection, and then you can do something with them. For example, let's say we just, for the sake of this example, want to show the name. And obviously, this is doing something on the elements and not actually returning anything. So we don't want to have this return value, and we don't have a result then. And now my initial displaying strategy here kind of reaches its limits because since you can only see the game view and this hierarchy here, we need a third window where you can actually see the console now because we want to do something new. Now when I go into play mode, you can see those three elements that have this class name being displayed. So that obviously is just symbolic for we can do whatever we want with them. In this case, we are just printing out their names. Okay, so we don't need this screen anymore. Let's just look at another example where we are doing actually something more meaningful, just to show you that now the thing that you get here obviously are the elements that you are kind of searching for. Because we used queried without a type, we can expect to get visual elements here, and then we can use all the properties on those visual elements inside of our for each loop. So in this case, let's just see if we can change the background color of all of those elements. And sure enough, that works. And obviously here, like the sky is the limit, you can do everything with those elements that you could do in, you know, every other part of your script. Let's exit play mode again. And just for those of you who are not familiar with this Lambda functions, or maybe are seeing this for the first time, don't be confused by that. That's really not complicated. This is just basically a function without a name that you are just that you just want to throw in and kind of don't make an extra declaration. Now, I already prepared something beforehand here to show you that how that actually works. Now, this first thing that you have before your error is basically the parameter that you are giving in. Now, from your selection, you have to know what type this parameter has. And as I said, because we are using an untyped query here, we know that this has to be a visual element. And now, so this is just a parameter. And then this is basically our function body, which is corresponding to what we are doing here. And if we actually want to write this function out, we can then equally use it by just using its name without opening and closing parameter, opening and closing brackets, and now we can see that we will get just the same behavior. Voila, and all of our elements are gray. So the function works just as before.